What if the future of skyscrapers isn't steel or concrete, but wood? It sounds impossible. For more than a century, cities around the world have reached higher and higher using steel and concrete. They built skylines, bridges, and some of humanity's greatest engineering achievements. So why are architects, engineers, and governments suddenly turning back to a material that humans have been using for thousands of years? Did we discover something new? Or have we underestimated wood all along? Because what is happening right now could completely change the future of construction. Let's find out. The material that never really disappeared. Before steel changed the world, wood already had. Long before cranes filled city skylines, long before reinforced concrete, long before steel towers, people built homes from wood. For thousands of years, timber protected families from the weather and supported entire communities. Then everything changed. The Industrial Revolution introduced stronger materials that allowed buildings to rise higher than ever before. Steel became the king of skyscrapers. Concrete became the foundation of modern cities. Wood slowly disappeared from the spotlight, or so it seemed, because behind the scenes, engineers never stopped improving it. Wood has been secretly evolving. The wood inside tomorrow's buildings doesn't look anything like the wood in your garden. Today's construction often uses engineered timber. One of the best-known examples is cross-laminated timber, or CLT. Instead of using a single plank, multiple layers of timber are glued together at right angles. The result is a large, strong structural panel capable of forming walls, floors, and roofs. Other systems include structural insulated panels, known as SIPs, which combine insulation with structural boards to improve energy efficiency. Prefabricated timber frame panels that arrive insulated and ready for installation. And complete modular rooms, built in factories with kitchens, bathrooms, and finishes already installed before being transported to site. Construction is becoming less like traditional bricklaying and more like precision manufacturing. Why the world is rediscovering wood. Why would modern cities choose wood over concrete? The answer begins with one word: carbon. Trees absorb carbon dioxide from the atmosphere while they grow. When responsibly harvested timber is used in buildings, much of that carbon remains stored inside the structure for decades. Compared with many traditional construction methods, engineered timber can help reduce a building's overall carbon footprint when responsibly sourced. But sustainability isn't the only reason. Modern timber buildings are also lightweight, precision manufactured, faster to assemble, and less wasteful on site. In many projects, large wall and floor sections arrive ready-made from factories, reducing construction time dramatically. Imagine building with giant building blocks instead of thousands of individual pieces. That's the direction construction is heading. Can you really build a skyscraper from wood? This might be the biggest surprise of all. Yes, modern timber buildings are reaching heights that once seemed impossible. The Atlassian Central in Sydney, Australia, currently holds the record as the world's tallest mass timber building, standing 39 stories high, using a hybrid design that combines a mass timber interior frame and floors with a steel exoskeleton and a reinforced concrete core. Projects in Norway, Sweden, North America, Australia, and other countries continue pushing the limits of timber construction. This doesn't mean every skyscraper will suddenly be made entirely from wood, but it proves something remarkable. Wood is no longer limited to small houses and cabins. It has entered the world of modern high-rise engineering. If wood is so good, why isn't every building made from it? Here's the question everyone asks. If timber is sustainable, fast, lightweight, why doesn't every city build with it? Because every building material has strengths and limitations. Timber must be protected from excessive moisture during construction. It naturally expands and contracts as humidity changes, so engineers design joints to accommodate movement. Fire safety also requires careful engineering. Following the Grenfell Tower tragedy, regulations in some countries, including the UK, restricted combustible materials in certain tall buildings, influencing how engineered timber is used in high-rise construction. Rather than replacing steel and concrete completely, modern construction increasingly chooses the right material for the right job. Sometimes that means combining all three. The factory revolution. What if your next home is mostly built before it even reaches your street? This is one of construction's biggest transformations. Instead of building everything outdoors, entire sections are now manufactured inside factories. Walls arrive insulated. Windows may already be installed. Bathrooms can be completely finished. Even kitchens can be fitted before the building reaches its site. Workers simply connect each section together. The result? Better quality control, less waste, faster construction, and fewer delays caused by bad weather. Some timber homes can become weathertight within just a few days once construction begins on site. For a world facing housing shortages, that's a major advantage. Conclusion: the future may look familiar. Sometimes the future isn't about inventing something new. It's about improving something old. Wood has been part of human history for thousands of years. Now, after centuries dominated by steel and concrete, it is returning. Not because we've gone backwards, but because technology has moved forward. Today's engineered timber is stronger, more precise, and more versatile than ever before. When sourced responsibly and used appropriately, it offers exciting possibilities for faster construction, lower embodied carbon, and innovative building design. At the same time, engineers continue to address important challenges such as fire safety, moisture protection, and structural performance. So, the future of construction is unlikely to be wood instead of steel or concrete. It is more likely to be wood working alongside them, with each material used where it performs best. The next time you see a modern building rising into the sky, take a closer look. It might not be made from what you think, because one of humanity's oldest building materials may also be one of the most exciting materials shaping the cities of tomorrow. And perhaps the biggest surprise isn't that we're building with wood again. It's that we ever stopped.